Okay, last example. We've got to find a third degree polynomial. So thinking back to the linear factorization theorem, if we have a third degree polynomial, we want 3 linear factors to make sure that we're completed, that we have a complete polynomial, and I'm going to have 3 zeros. So I'm going to write down my leading coefficient, and I should have 3 factors. Now it tells us that one of the zeros is -5, so that means I should have a factor of x plus 5. One of my factors is 4 plus 3i, so I should have a factor of x minus 4 plus 3i. And then because of the conjugate theorem, we want to make sure that we also have the conjugate as a 0. So I'm also going to have x minus 4 minus 3i, because those are conjugates. Now I can clean this up a little bit because I don't have double parentheses in there. So x minus 4, and then minus 3i, and then x minus 4, and then plus 3i, because I get that minus a negative 3i gives me a plus 3i. Now I'm going to use the extra point that is given to me to plug in for x and y, and that way I can find my leading coefficient. So I'm going to plug in 91 for y, and I'm going to plug in 2 for all my x's. So the 2 plus the 5 gives me a 7. I'm going to do this on my calculator to make it easier. So in parentheses on my calculator, I'm going to put parentheses 2 minus 4 minus 3i, close parentheses, and then open parentheses and put in 2 minus 4 plus 3i, close parentheses. And don't forget your I button is right above the period, and you have to use your second button to access it. So when you put that in on your calculator, you're going to find that that big mess right here is actually equivalent to just 13 when you multiply that out. Okay, then I take 7 times 13, that gives me 91. So I get 91a is equal to 91. So in this case, that big mess simplifies to 1. Wow. So my final answer is going to be P of x is equal to 1 times x plus 5, x minus 4 minus 3i, and x minus 4 plus 3i. And there is my final answer.